Nate the mathematics guy.
Nate.
Nate the mathematics guy.
YouTube viewer, come on down. You're the next contestant on Let's Make a Deal. Alright, beneath one of these 3 cups is a set of keys to a new car! Woo! In a moment, I'm going to ask you to choose one. Okay, there we have the 3. Alright, go ahead and choose one. This one, this one, this one. Okay, this is your choice. Okay, but before we reveal the answer and find out if you have won or not, let's up the suspense just a little bit. So I'm going to up the suspense and pick one of the cups you did not choose. This one. Let's go ahead and reveal it. May I have a drum roll, please? Nothing! Alright, the suspense is growing. This is the cup that you chose. This is the other cup. Now I'm going to give you a chance to change your mind. Do you want to change your mind and pick the other cup? Yes, you do want to change your mind? Alrighty. Let's see if you were right. So this was the original cup you chose. You changed your mind. If the keys are under this cup, you lose. Well, let's reveal it. Whoosh. No, that means you've won! You have the keys to a brand new car! Woo!
Monty Hall.
This puzzle is named after Monty Hall, the game show host of Let's Make a Deal. And while Monty Hall had actual doors and actual cars behind them, his studio is a lot bigger than mine, so I use teacups instead. Before it can really be fair to ask you the question of whether it's better to change your mind or not, we really do need to agree on a precise standard protocol so we can calculate exactly what that question means. So here's the protocol. The host hides the prize. There's only one, under one of the 3 cups. No one besides the host knows which cup hides the prize. And we'll also assume that you can't read his body language, or there are no other clues, no possible way to know which cup hides the prize. Okay, you choose one of the 3 cups. The host then reveals one of the cups that is neither A, the one you chose, nor B, the winner. Since if he did reveal one of these cups, the game would immediately end at this point, and we're going to assume that doesn't happen. The host can always do this because notice there are 3 cups, and so there's always going to be at least one cup that he can reveal. Therefore, the prize must be under one of the 2 remaining cups. The host then offers you a chance to change your mind to the other unrevealed cup. Is it better to switch? I mean, really, after all, there's only 2 cups left. The prize is under one of the cups or the other one. So what does it really matter if you change your mind or not? It's 50-50 either way, right? So it's not any better to change your mind, is it? Well, the surprising answer is yes! It is better to change your mind. In fact, you're twice as likely to win if you do. I'm sure you're wondering at this point, is Nate the math guy crazy? I mean, how can this possibly be, right? It just seems so completely and bogusly wrong. And in fact, actually this problem first came to national attention when Marilyn Vos Savant, in her Parade magazine article, published an article on it, and thousands of people ended up responding to it, and even PhD mathematicians got this one wrong. So it's a wonderful illustration of the danger of irrational thinking. And a reminder that just because you have the letters PhD in front of your name doesn't necessarily make you right. In fact, I'm working on a PhD myself, and I will readily admit that it does not qualify me to be automatically right. And even PhD mathematicians can be wrong about math. So, let me try to explain why this is, the solution to this problem is what it is. Think about it this way. Let's suppose you have two hypothetical people. You have Bob on the one hand, who is a stick-to-his-guns kind of person. He never changes his mind. Once he's made a decision, he sticks with it. And on the other end, you have Tom. Tom is a guy who's very fickle. He changes his mind all the time. Tom will always change his mind if given the opportunity. Okay, and let us ask ourselves, is one of these two people more likely to win at this game show? Well, let's work it out. So, first I'll stand over here and pretend to be Bob. So I am Bob, and I make one of my three choices. Now, more than likely I'm wrong. Reason being, there are three choices, and I'm only choosing one of them, so I've only got a 1/3 probability that my choice was correct. But I never changed my mind, so one time out of three, my choice will be correct. The host will reveal one of the other cups, but I will stick to my guns and stick with my choice, and I will win. However, 2/3 of the time, I will make the wrong choice. The host will offer me a chance to change my mind, I won't, and so I will lose. So I am Bob, and I will win 1/3 of the time. Alright, now let's go over and talk to Tom. Hello, Tom. I am Tom. 1/3 of the time, the first choice I make will have been right. Poor me. In that case, I made the right choice. The host will reveal one of the other two cups. In this case, he can open either one of them because I made the right choice. And then he will ask me to change my mind. And I'll think, gosh, maybe I should. And I'll change my mind, and then he'll open it, and I'll be like, oh, I should have chosen the other one. I should have stuck with my original choice. But that'll only happen 1/3 of the time. The other 2/3 of the time, I will make the wrong choice when I first pick a cup. And then, there's only one cup the host can possibly reveal, because the other cup is the winner, and he can't reveal the one that I chose, so he'll go ahead and reveal the one cup that he can reveal, upping the suspense, but not really. The host knows full well when he reveals that cup that there's going to be nothing under there, because he knows which cup hides the prize. And then, he will ask me to change my mind, and being Tom, I will change my mind, and I will win the prize. I will get it right. So Tom will win 2/3 of the time, and Bob will only win 1/3 of the time. Meaning, it is twice as good to change your mind in this case. Think about that for a while. It takes a little bit to sink in, but it really is true.
Nay, the mathematics guy.